Dear students, so in this class now let us discuss an important theorem. That's an important property of a Riemann integral. What about the Riemann property for a composition of two functions? So now let us discuss about when a function f, consider a function f, let I equals cos t. Consider two intervals. I equals cross interval AB and j equals cross interval CD. Now f from I to R is integrable on I. And phi from j to R is a continuous function. So what about the nature of the composition, phi composition f? Here we discuss about the composition of a continuous and integrable function, whether it is integrable or not. That's our aim. Here I is crossed interval AB, j is crossed CD, and f from I to R is continuous. It is integrable function on I, as well as phi from j to R is continuous function on j. Then what about the Riemann integrability of phi composition f? That's our aim. Here the theorem states that when f and phi satisfies these conditions, then the composition phi composition f is always integrable. Phi composition f is integrable. That is our requirement. So how to prove this one? So first we define let k equals supremum mod phi of x. Supremum modulus of phi of x for x following j. What is phi? Phi is defined as phi from j to R, which is what is j? Closed interval CD. So phi from j to R is a continuous function. K is supremum mod phi of x. Let k equals supremum mod phi of x, where x following j. Let h equals phi composition f. What is f? What is phi? Phi is continuous. Phi is continuous means phi is continuous on where? On j. What is j? J is closed CD. Means phi is continuous on a closed interval. We already know that the continuity on a closed interval should imply uniform continuity. So clearly phi is uniformly continuous. Phi is uniformly continuous on j. That means that implies for all x comma y following j, modulus of x minus y less than delta, then modulus of phi of x minus phi of y should strictly less than some epsilon dash. Okay, what is epsilon dash? You can define this epsilon dash in such a way that epsilon dash equals some epsilon by b by epsilon by b minus a plus 2k and whatever may be. So since phi is uniformly continuous, by the definition of uniform continuity, it is if modulus of x minus y less than delta, then modulus of phi of x minus phi of y should strictly, modulus of x minus y less than delta, then modulus of phi of x minus phi of y should strictly less than some epsilon dash. Now since f is integrable on I, then what is delta? Delta is a sufficiently small positive quantity. Surely delta square is also positive. Then consider a partition. Since f is integrable on I, means there exists a partition P. What is this P? The partition P is P equals some x naught, x1, etc. xn of closed interval AB such that UPF minus LPF strictly less than some epsilon. Instead of epsilon, it is some delta square. Whatever. F is integrable on I means there exists a partition by definition by the Riemann criteria. There exists a partition P of closed AB such that UPF minus LPF strictly less than delta square. What's our requirement? Our requirement is to show that phi composition F is integrable on I. So in order to show that U phi composition F, what is phi composition F? H. So we have to show that UHF minus LHF strictly less than some epsilon. That's our requirement. Agreed. So for let capital MK equals supremum mod of supremum of f of x, where x fall in closed interval xk minus 1 xk. Similarly, small mk is infimum of f of x for all x fall in closed interval xk minus 1 xk. Now we define mk cap. Mk cap equals supremum h of x, where x fall in closed interval xk minus 1 xk. And the small mk cap equals infimum h of x for all x fall in this. So we define this capital MK, small mk, capital MK cap and small mk cap in such a way that mk is supreme f of x, small mk is infimum f of x, capital MK cap is supreme h of x, and the small mk cap is infimum h of x for all x fall in closed interval xk minus 1 xk. Agreed. So, but UPF minus LPF strictly less than delta square. So what is UHF minus LHF? That is sigma S capital MK cap minus small mk cap into delta xk. Agreed. Now consider a set. Consider the set 1, 2, 3, etc. up to n. Consider this set. So you divide this set 1, 2, 3, etc. up to n into two subsets such that one is A. Divide this set 1, 2, 3, etc. up to n in such a way that A equals set of all k with a capital MK minus small mk strictly less than that. Okay. And B equals set of all k such that capital MK minus small mk greater than or equals to delta. You can divide set 1, 2, 3, etc. up to n into two mutually disjoint intervals such as in this one. A equals set of all k with a mk minus mk less than delta. B equals set of all k with a capital MK minus small mk greater than or equals to delta. Clearly, A intersection B is empty. They are mutually disjoint, but A union B is the given set of 1, 2, 3, etc. up to n. Okay. Now, what about UPH minus LPH? UPH minus LPH. UPH minus LPH equals UPF instead of F, here is H. UPH minus LPH equals sigma over K capital MK cap minus small mk cap into delta x. Okay. So that is nothing but which is same as sigma over k foreign A of capital MK cap minus small mk cap into delta xk plus sigma over k foreign B capital MK cap minus small mk cap into delta x. Clear? Why? Because this set 1, 2, 3, etc. up to n, that is depends upon this delta which divides into two of the subintervals. Agree? So UPH minus LPH is nothing but sigma over k foreign A of this one plus sigma over k foreign B of that. Enough? Now there are two case arises. Which are them? The first case is when k fall in A. What happens? If k fall in A, what happens? If k fall in A, K fallen A means mk minus small mk strictly less than delta. That is by the choice of A, by the construction of A. Mk minus mk, what is mk? It is supreme of f of x. What is small mk? Infimum of f of x less than delta. So that means modulus of it is some f of x minus f of y less than delta, where x comma y fall in closed interval xk minus 1 xk. Closed interval xk minus 1 xk. Okay. By capital MK minus small mk less than delta, this is for xk for x fall in closed interval xk minus 1 xk. Mk supreme mod f of x, small mk infimum mod f of x. So it is modulus of f of x minus f of y less than some delta for all x comma y fall in closed xk minus 1 xk. What is phi? Phi is a continuous function. Since phi is a continuous function, so it is uniformly continuous over G. So it is modulus of phi composition f of x minus phi composition f of y strictly less than delta for all x comma y fall in this one. Why? Because phi is continuous. The crucial point here is phi is a continuous function. Okay. What is phi composition f? That is by the choice, it is nothing but h. So it is modulus of hx minus hy strictly less than delta for all x comma y fall in closed interval xk minus 1 xk. Agreed? So modulus of hx minus hy strictly less than some delta, or here modulus of phi of x instead of here modulus of phi composition f of x minus phi composition f of y strictly less than some epsilon dash. Why? Because we say that phi is uniformly continuous on J, and modulus of phi of x minus phi of y less than epsilon dash. That is by the choice. Clear? Phi is uniformly continuous on J. Since J is a closed interval, phi is uniformly continuous on J. Then we already say that it is modulus of phi of x minus phi of y less than epsilon dash. So for here, modulus of phi composition f of x minus phi composition f of y less than epsilon dash. So here it is modulus of hx minus hy less than epsilon dash for all x comma y fall in xk minus 1 xk. Modulus of hx minus hy means it is mk cap minus small mk cap strictly less than some epsilon dash. Okay. What is mk cap? Supreme mod h of x. Small mk cap infimum mod h of x. So when modulus of hx minus hy less than delta epsilon dash, then we can conclude that mk cap minus mk cap strictly less than epsilon dash. So that means taking sigma on both sides, sigma mk cap minus mk cap strictly less than into delta xk strictly less than sigma epsilon dash into delta x. Agreed? So what is that equals epsilon dash into sigma delta xk. What is sigma over k delta xk? It is b minus a. So that's our first result. Sigma mk cap minus small mk cap into delta xk strictly less than epsilon dash into b minus a, that when k fall in a, what is mk cap? Supreme mod h of x. This is infimum mod h of x. So clearly sigma upf minus lpf less than some epsilon dash into this one, uhf minus uhp minus uph minus lph. So that means it is integral. So when k fall in a, the result hold here. Okay. Now our second case. What's our second case? On second case, k fall in b. That's our second case. If k fall in b, what is b? B is constructed as set of all k such that modulus of it is mk minus small mk greater than or equals to delta. Capital Mk minus small mk greater than or equals to delta. That means capital Mk minus small mk by delta greater than or equals 1. Agree? That is greater than or equals 1. Also we know that mk cap minus small mk cap, which is less than or equals modulus of mk cap plus modulus of mk cap. Modulus of a minus b, we know that this result. A minus modulus of or a minus b less than or equals mod a plus mod b. Mod a minus b less than or equals mod a plus mod b. Since they are positive, so mk cap minus mk cap less than or equals mod mk cap plus modus mod mk. What is k? K is supremum mod of k is supremum mod of phi of x. This is k. Mk cap is supremum mod of h of x. H is nothing but phi composition f. So it is less than or equals k plus k equals to k. Okay. Right. Therefore, sigma over k fall in B, sigma over k fall in B, capital Mk cap minus small mk cap into delta xk into delta xk, that is less than or equals mk cap minus mk cap less than or equals 2k. Sigma over k fall in B 2k into delta xk. Agree? That is 2k into 2k into delta xk.